This is a video on working with a high power LED for making carbon stick Gans. In a previous attempt to make CO2 Gans, I used a common 5mm LED. One can see that the green LED is glowing amber color in that earlier attempt. This was a sign that the LED was overheating due to the current overload. I burned out about 3 or 4 LEDs in that batch. I tried adding a current limiting resistor in subsequent batches, but I didn't get a good result. That's what led me to believe that I needed an LED that could handle more current. After some trial and error, I made my first high power LED board using a 1-watt chip. I mounted the chip on a Perf board with copper foil pads to attach the alligator clips from the power supply. The leads on a high-power LED chip are very fragile and could easily break off in a work environment. The following steps describe how to make a more durable unit by mounting the LED onto a Perf board. Please see the description for links to the materials. The cathode is stamped with a hollow area as well as a minus sign. The anode is stamped with a plus sign. Tape the chip to the board. Solder one of the leads to a pad. Solder the other lead to a pad. Remove the tape. Solder a red wire to the anode. Solder a black wire to the cathode. Make pads from 5mm copper foil. Melt some blobs of solder where the pads will go. Hold one of the pads with an alligator clip. Heat the copper pad with the broad side of the soldering iron to melt the blobs of solder. Repeat the process for the other pad. Clip one of the wires over its pad. Solder it to the pad. Repeat the process for the other pad. This 1-watt LED is running at 735.3 milliwatts, so it should be in a safe range. The setup is powered by a 12-volt AC adapter that is rated at 900 milliamps. I made a 3-watt version with an LED chip, then I made another 3-watt version with a heatsink. Okay, I want to shoot this video of an improvement I made on the high power LED board. I'm going to unplug it because the glare is too much. So okay, so I unplugged it. Now I'm going to just bring this over here. And okay, now this one. Okay, I'm going to show side by side. Now this is the original test version. It's just the LED chip without a heatsink, and that's important. The heatsink is important because it will help extend the life of the LED by keeping it cool. I used a star PCB LED and attached it to the heatsink with thermal glue. This is the thermal glue that I used. The heatsink that I used was designed for use with star PCB LEDs. I got it online at eBay and cut it to fit the board. The heatsink is mounted to the board with 2 sheet metal screws, and then in order to keep it from wobbling around, I put 4 machine screws on the corners and secured them with nuts, because so it would be stable. This is a batch of CO2 Gans I ran after making my first high-power LED board. At the time it was running for about 4.5 hours. I shut it down about a half an hour later. I hope you liked the video. Thank you for watching.